You think time travel is science fiction? You think it belongs only to movies, to DeLoreans, to wormholes, to flickering clocks and paradoxes? Think again. Time travel isn't magic. It's physics. And it's already happening right now to astronauts on the International Space Station. Just a few milliseconds per year. But what if we could go faster? Much faster. Not just near light speed, but close enough that time itself begins to bend. What if we build a ship that could reach 99% of the speed of light? Not for exploration, not for discovery, but to escape time, to outrun death, to arrive in a future where everyone you ever knew is dust. And yet, you would still be alive. This isn't fantasy. This is the most terrifying, beautiful, and scientifically possible journey humanity might ever take. Einstein didn't invent time dilation. He discovered it. In his theory of relativity, he showed that time doesn't flow at the same rate for everyone. The faster you move, the slower time passes for you. This isn't theory. It's proven. Atomic clocks on GPS satellites run slightly faster than clocks on Earth because they're moving faster relative to the ground. Tiny differences, but real. Now imagine traveling at 99% the speed of light, nearly 1 billion kilometers per hour. At that velocity, time slows down by half. For every year you spend on the ship, 2 years pass on Earth. Fly for 10 years and return to find your grandchildren grown old. Your parents gone, your friends buried. Your world changed beyond recognition. You didn't jump through time. You simply outran it. And that's the price of reaching the edge of physics. Stephen Hawking once proposed a way to accelerate this effect even further, not with speed alone, but with gravity. Near a black hole, space-time bends so violently that time almost stops. If you could orbit a supermassive black hole, like Sagittarius A*, asterisk at the center of our galaxy, for a million times heavier than the sun, without falling in, you could stretch time even more. At a safe distance of 45 million kilometers, circling at 99% light speed, one orbit around the black hole would take just 8 minutes for you, but 16 minutes for someone far away. After 10 years of these orbits, you'd have aged 10 years. Everyone else, 20. You'd return to Earth as a man who had lived a decade, and find a world that had moved forward 2 decades. But here's the catch. No human can survive that close. The tidal forces would tear you apart. The radiation would fry your cells. The magnetic fields would rip your atoms from your bones. So while the math works, the reality is suicide. We don't need black holes to time travel. We just need speed. To reach such speeds, you need fuel. And not just any fuel. You need mass, tons of it. Enough to push a ship to near light velocity. But carrying that fuel from Earth is impossible. The rocket equation doesn't allow it. The energy required grows exponentially. To accelerate 1 kilogram to 99% light speed takes more energy than all the power plants on Earth produce in a year. So the ship wouldn't launch from Earth. It would be built in orbit, assembled piece by piece over decades. A structure larger than the International Space Station. A vessel weighing millions of tons. Only then, when it floats in the silence between planets, would its engines ignite. And even then, acceleration would take 6 years. Slowly, carefully, gently, so the crew doesn't turn to paste under the G-forces. By the time they reach 99% light speed, they've traveled farther than any human has ever been. And they haven't even left the solar system yet. Inside the ship, everything feels normal. You walk, you eat, you sleep, you talk, you laugh. Because from your perspective, time flows normally. You don't feel slow. You don't feel strange. You don't feel like you're traveling into the future. That's the cruel twist. You are changing the universe, but you don't feel it. Only those left behind do. For them, you vanish. For you, you just keep going. And as you approach light speed, the outside world begins to warp. Stars ahead turn blue. Stars behind turn red. The cosmic microwave background, the faint glow of the Big Bang, becomes a blinding wall of gamma rays. The entire sky compresses into a single point of light directly ahead. You see nothing of space anymore, only a tunnel of fire. And then you realize you're not flying through space. You're flying through history. But here's the nightmare no movie shows. At 99% light speed, even the tiniest speck of dust becomes a bomb. A hydrogen atom hitting your hull carries the energy of a proton fired from the Large Hadron Collider. A grain of sand, equivalent to a nuclear warhead. The interstellar medium, thin as vacuum, but filled with particles, becomes a lethal storm. Every second, you're hit by 10,000 high-energy particles. Normal radiation exposure on Earth, 6 millisieverts per year. On this ship, 10,000 sieverts per second. That's a billion times lethal dose. Instant death. No warning. No pain. Just gone. Shielding won't help. Lead is useless. Water is pointless. Even meters of graphene or boron nitride would vaporize. The only solution? Fly through empty space. Avoid stars. Avoid nebulae. Avoid anything with matter. And hope. Hope that the universe is kind enough to leave you a path. But space isn't empty. Not really. And you're moving too fast to dodge. Forget Star Wars. Forget hyperspace lanes. Forget glowing trails. At near light speed, the Doppler effect turns the universe into a single, blinding disk of radiation ahead. Behind you, total darkness. The stars don't streak past. They vanish. The Milky Way collapses into a narrow ring. The cosmic background radiation shifts from microwaves to gamma rays. Lethal, invisible, overwhelming. You cannot look out the window. You cannot see the stars. You cannot see Earth. All you see is a white-hot disk, the accumulated light of billions of years compressed into a single beam. And you are hurtling into it faster than any particle in nature. You're not a traveler. You're a bullet, fired from the past, aimed at the future with no one left to receive you. We may never send humans, but we're already building ships that will fly at 20% light speed. That's 160 million kilometers per hour, faster than anything ever launched by humankind. The project is called Breakthrough Starshot, funded by Yuri Milner, advised by Stephen Hawking, designed by physicists at Harvard, MIT, and Caltech. The spacecraft? A tiny chip smaller than a cookie. Weight? Less than a gram. Equipped with cameras, sensors, communication lasers, solar sails made of ultra-thin graphene. Launched not by rockets, but by a ground-based laser array 100 kilometers wide. A pulse of 100 gigawatts, focused for minutes, accelerates the sail to 20% light speed in seconds. No fuel, no engine, just light pushing a mirror. In 20 years, it reaches Alpha Centauri, for 0.37 light years away. Sends back images, maybe finds planets, maybe finds life. Then silence, no return, no message home. It flies on, forever, a ghost in the dark. We built it. We sent it. We'll never see it again, but we'll get the pictures. And for the first time, we'll see another star system, not as it is today, but as it was 4.37 years ago. Imagine you're on a ship. You leave Earth. You fly for 10 years at 99% light speed. You return. You step out. The air smells different. The sky looks wrong. People speak differently. Technology is unrecognizable. Your parents? Gone. Your children? Great-grandparents. Your childhood home? A museum. Your name? Forgotten. You're a relic. A survivor. a living fossil. You didn't die, but you lost everything. You didn't travel through space. You traveled out of time, and there is no map back. Perhaps this is why we haven't met aliens. Not because they don't exist, but because they're too far, too late, too fast. Maybe a civilization reached light speed 50,000 years ago. They explored the galaxy, sent ships, found worlds, but when they returned, their home was gone, their language forgotten, their species extinct. So they stopped. They waited. They became quiet. Maybe they're still out there, floating in ships, frozen in time, watching the universe age without them. Maybe they're sending signals, but we're not listening because we're too slow. We're still crawling, still burning fuel, still waiting for rockets, while they flew into the future and vanished. A ship that reaches light speed won't be a marvel of engineering. It will be a tomb, a coffin made of steel and dreams. It won't carry heroes. It will carry the last people who refuse to accept that time is final. We want to touch the stars, but the stars are not places. They are moments. And to reach them, you must leave your own moment behind. You must trade your present for their future. You must become a ghost, so that others, centuries from now, can say, they went, they saw, they came back, and found us waiting. We hope this journey ignited your curiosity. Stay with us as we explore the edges of physics where time becomes a prison and speed becomes salvation. Subscribe and join us for the next discovery.